it's showing that it's true and it's 0.44. And if we go back and we change this to Bill Gates, now this gives us false, and it gives us a value of 0.84. So next we are going to create an attendance project based on this facial recognition library. So let's go ahead and create a new file. We will call this attendance project. And what we will do is we will first import our libraries as we did before. So let's copy that. So now let's look at the steps. The first step is again to import your images and then convert them into RGB. So this is the first step. Now, but if you look at this, whenever we have to bring in a new image, we will have to write it manually, give it a name, and then store it and find its encodings. That will be a very messy process. So what we can do is we can create a list that will get the images from our folder automatically, and then it will generate the encodings for it automatically, and then it will try to find it in our webcam. So to do that, as you can see here, we have the images attendance, and we have 3 people here: Bill Gates, Elon Musk, and Jack Ma. So what we will do is that we will ask our program to find this folder and find the number of images it has and import them and find the encodings for them. So to do that, we are going to use the OS. So we will write import OS, and then we will first import our images. So we will write here path is equals to images attendance, and then we will create a list of all the images we will import. So we will call this images, and then we will also write the names of all these images. So we will take the names of each one of them, and when we output the result, we will use these names. So instead of creating a new list where we have to manually type all the names, we can just take it from our image itself. So here we can write, let's call it class names. So the first thing we will do is we will grab the list of images in this folder. To do this, we will write mylist is equals to os.list directory, and we will give it a path. So if we print this out, so as you can see, we have Bill Gates, we have Elon Musk, and Jack Ma. So we have all the 3 images. So next we are going to use these names and import the images one by one. So we can write here for CLS, which is our class in our mylist, we are going to import each of the classes. We can use the load image, but here we are going to use the normal ImRead function that comes with OpenCV. So we can write our current image is equals to cv2.imread, and then we will read our current image, which is basically our path, and then slash, and then CL. CL is the name of our image. So for example, the first one will be billgates.jpg. So CLS class, or let's put it without the S. Then we are going to append, so we will say images dot append, and we are going to append our current image. And the last thing we will do is to append our class name as well. So class names dot append, and inside here we don't want to append just the name like this because it's billgates.jpg. We just want Bill Gates. So to do that, we can write os.path.splitText, and we want to split CL, and then we will grab the first element of it, which is 0. So this will give us Bill Gates instead of billgates.jpg. So we can print this out to see if it works properly. Class names, and let's comment this out. So as you can see, the list was like this before, and now it is without the extensions of the files. Okay, so next we are going to start with our encoding process. So we know that once we import our image, we have to find the encodings for each one of them. So what we can do is we can create a simple function that will compute all the encodings for us. So we can write here find encodings, and we will require a list of images. So images, then we will create an empty list that will have all the encodings at the end. So we will call it encode list is equals to empty, and then we are going to loop through all the images. So for img in images, so the first thing, as you know, we have to convert it into RGB. So we will copy this line. So our image is equals to image converted to RGB. Then the next step is to find the encodings. Now to do that, I think this part is done, so we can remove this. Let's go back to the basics, and let's actually copy all of this, and then we can paste it here, and then we can comment it out. So the next step is to find the encodings. So here you can see we are finding the encodings. So we can write here encode, and then over here we can just make it image. So this will find the encodings, and then we will just append it to our list. So encode list dot append, and then we will write encode. And at the end we will just return this, return encode list. Now to run this, we just have to call this function. So we will say encode list for known faces is equals to find encodings, and we will send in our images. Now to test if it works properly, we can print out the length of our encoded list known. So let's run that. And there you go. So now we can see we have 3 encodings in our list. So we don't need to print this, but what we can do is we can print whenever we have found the encoding, so that, because it takes a little bit of time, so we can write encoding complete, so we know it has done this step. So now we are moving on to the third step. The third step is to find the matches between our encodings, but we don't have an image to match it with. Now that image will be coming from our webcam. So let's initialize the webcam. So we will write cap is equals to cv2 dot video capture, and we will give it 0